Fact family, multiplication division, level 1. Fact families are a series of true equations involving the same number, and in this video, we're exploring the relationship between multiplication and division. Let's take a look at our first multiplication problem. Here we have 3 times 4 equals 12. The way I like to think of multiplication is, I like to think of the first number as how many groups I have. So I'm going to have 3 groups. I like to think of the second number as how many objects I'm going to have. So when I see the equation 3 times 4, I like to think of that as 3 groups of 4 objects. Now let's go ahead and test if this is going to be true. So 3 times 4 equals 12. I'm going to need 4 objects, 1, 2, 3, 4, for these dots. And I'm going to place that inside of a group. Now times 3 means I want 3 of these groups, so times 2 times 3. And I can see that 3 groups of 4, 3 times 4, I'm going to have 12 dots altogether. So 3 times 4 is 12. So I know that this first equation is true. Is there another multiplication problem I could write involving these same numbers? Another equation I could write could be 4 times 3 equals 12. And just like the other example, the way I like to think of this is I have 4 groups, each containing 3 objects. So 4 groups of 3 objects. Let's go and check to see if this is true. So starting with my 3 objects, 1, 2, 3. I'm going to place these inside of a group. And now I want 4 groups. So times 2, times 3, times 4. 4 groups of 3, 4 times 3. And I can see that I also get a total of 12 dots. So that second equation is going to be true. Now that we have our 2 multiplication problem, is there a division problem I could write involving these same numbers? A division problem I can think of is 12 divided by 4 equals 3. The way I like to think about this problem is I have 12 objects, this time divided into 4 groups. And the answer is going to be in one group, I have 3 objects. So let's go and see if this is true. So here we're starting off with 12 dots, and I'm going to sort them into 4 equal groups. So here's 1 group, 2 groups, 3 groups, 4 groups. And notice that when I divide it into 4 groups, in one bubble, in one group, I have 3 objects. So 12 divided by 4 equals 3. Now, what's the final division problem I can write involving these same 3 numbers? The last division problem I can write is 12 divided by 3 equals 4. And the way I like to think of this, I have 12 objects, this time sorted into 3 groups, giving me each group has 4. So 12 divided by 3 equals 4 per one group. Now let's go and see if this is true. Starting with 12 objects, dividing into 3 equal groups. So divided by 1 group, 2 groups, 3 groups. I see that in one group I have 4. So 12 divided by 3 equals 4. So that equation is going to be true. Now let's go and go over another example and see if we can figure out what all the fact families are going to be. So starting here, we have 5 times 2 equals 10. And I can test to see if that's true. Here I have 2 objects placed inside of a group. And now I want 5 groups. Times 2, times 3, times 4, times 5. I see that 5 groups of 2, 5 times 2, equals 10 dots, which is true. What's another multiplication problem I could write? I could write 2 times 5 equals 10. What's that going to look like? Starting with 5 objects, 1, 2, 3, 4, 5, putting those in the group, and times 2 groups. I see that 2 groups of 5, 2 times 5, is going to be 10 dots as well. So I know that equation is going to be true. What's a division problem I can write involving these numbers? One division problem I can write is 10 divided by 2 equals 5. And the way I like to think of that is I have 10 objects, and I'm going to divide them into 2 groups. So 10 objects divided into 2 groups. Notice that in one group I have 5 dots. So 10 divided by 2 is 5. And finally, what's the last equation I can write involving these numbers? I could write 10 divided by 5 equals 2. Starting with 10 objects, I can divide into 5 groups, 1, 2, 3, 4, 5. And notice that in each group I have 2. So in one group I have 2 dots. Hopefully you kind of saw a pattern between how we came up with our multiplication and division problem? The way I like to think of it is, if I multiply two parts, I'm going to multiply to the whole amount. And if I take the whole amount and divide it by one part, I should get the other part.